You're standing in Richmond Shipyard Number 2 in California on September 15, 1943, wearing welding leathers that Louise Cox designed specifically for women workers, holding welding torch that weighs nearly as much as your 8-year-old daughter, preparing to weld 50-ton hull section that male shipyard veterans insist women can't possibly assemble properly. Your name is Dorothy Miller, 32-year-old former waitress and housewife from Missouri who arrived in Richmond 6 months ago after your husband enlisted in Army, leaving you sole provider for 3 children. You completed 6-week welding training program that traditional shipbuilders dismissed as completely inadequate for producing competent welders. German naval architects, studying American shipbuilding methods called Kaiser's prefabrication system stupid, amateurish, and fundamentally flawed. Predicting ships built by inexperienced workers using modular construction would fall apart in heavy seas, killing American merchant sailors. Yet here you stand, one of over 20,000 women employed by Kaiser shipyards, preparing to prove German experts and American skeptics completely wrong by helping build Liberty's ship in 42 days that traditional shipyards require 6 months constructing. Around you, hundreds of other women work as welders, riveters, crane operators, electricians, pipe fitters, performing skilled industrial labor that society insisted only men could accomplish. You're part of industrial revolution transforming not just American shipbuilding but women's roles throughout society. Success or failure in this moment matters beyond immediate military necessity. If women succeed building ships faster than Kriegsmarine can sink them, you prove women's capability for industrial work, challenging centuries of assumptions about gender limitations. If you fail, critics will use failure as evidence women can't handle skilled trades, justifying excluding women from industrial employment for generations. Context of your arrival at Richmond shipyards represents larger transformation occurring across American industrial landscape. Before Pearl Harbor attack December 7, 1941, American shipbuilding industry employed approximately 3,000 workers in Bay Area building ships using traditional methods where skilled craftsmen spent years learning trades through apprenticeship programs. Shipbuilding was exclusively male profession, requiring physical strength and technical knowledge that society assumed women couldn't possess. Pearl Harbor changed everything. Massive expansion of naval forces and merchant marine required unprecedented shipbuilding capacity. Simultaneously, military conscription removed millions of men from civilian workforce, creating labor shortage, threatening industrial production. Government and industry leaders initially resisted employing women, arguing that shipbuilding required male physical capabilities and that training women would waste resources because women lacked aptitude for mechanical work. Kaiser challenged those assumptions, arguing that labor shortage necessitated utilizing all available workers regardless of gender. Kaiser proposed hiring women, providing training, adapting work environments, accommodating women's needs, giving women opportunities, demonstrating capabilities. Traditional shipbuilders predicted disaster. Maritime Commission officials expressed skepticism. Union leaders protested, arguing that hiring women would undermine wage standards and threaten male employment. Kaiser proceeded anyway, recognizing that wartime emergency required unconventional solutions regardless of peacetime prejudices. Your personal journey from Missouri waitress to California shipyard welder exemplifies larger migration patterns during war years. Richmond population exploded from approximately 24,000 before war to over 100,000 by 1943 as workers flooded regions seeking defense employment. Women comprised substantial portion of that migration. Some women like you came because husbands enlisted, leaving families without income. Some women came seeking better wages than traditional female employment offered. Some women came seeking adventure and independence that wartime disruption of social norms enabled. Whatever motivations brought women to shipyards, all faced skepticism from male co-workers, resistance from union leadership, discrimination from supervisors, societal disapproval from people insisting women belonged home, caring for families rather than working in dangerous industrial facilities. Yet women persisted because financial necessity, patriotic duty, personal ambition, or combination motivated them continuing despite obstacles. Training program you completed represents innovation, enabling rapid workforce expansion. Traditional shipbuilding apprenticeships lasted years, teaching comprehensive knowledge about entire shipbuilding process. Kaiser's training lasted 6 weeks, teaching specific specialized tasks rather than comprehensive skills. That specialization enabled rapid training because workers didn't need understanding entire ship construction, only their specific operations. Welding training taught different welding positions: flat, horizontal, vertical, overhead, using training fixtures replicating actual shipyard conditions. Training emphasized safety procedures, quality standards, productivity expectations. Physical conditioning prepared women for strenuous work requiring climbing ladders, lifting heavy equipment, working in confined spaces, maintaining uncomfortable positions for extended periods. One gynecologist working at shipyards developed fitness program specifically preparing women for physical demands, including scaffolding erected outside welding school where women practiced climbing high ladders with loads, developing strength and confidence necessary for shipyard work. Traditional shipbuilders dismissed training program as inadequate, arguing 6 weeks couldn't possibly produce competent welders. Kaiser argued that specialized training combined with simplified assembly procedures enabled adequate performance for wartime emergency when perfection couldn't be achieved, but adequate quality in massive quantities proved sufficient, winning war. Modular prefabrication system that German naval architects derided as stupid actually represents brilliant innovation, adapting mass production principles to shipbuilding. Traditional shipbuilding constructed ships sequentially starting with keel, then building upward, adding components piece by piece in specific order. That sequential approach required skilled workers understanding entire ship structure because each component must fit precisely with previously installed components. Kaiser's modular approach divided ship into massive prefabricated sections: bow units, stern units, deckhouses, engine rooms, built simultaneously in different fabrication areas, then assembled using massive cranes positioning sections onto construction ways where welders joined sections together. That parallel construction dramatically reduced total construction time because multiple sections proceeded simultaneously rather than sequentially. Prefabrication enabled specialization where workers repeatedly performed specific tasks, becoming extremely efficient through repetition rather than requiring comprehensive shipbuilding knowledge. Critics argued modular construction produced inferior ships because continuous welded connections between large sections created structural vulnerabilities that traditional riveted construction avoided. Kaiser countered that quality control procedures combined with improved steel specifications and design modifications prevented structural problems while achieving production rates 10 times faster than traditional methods. German criticism of American methods stemmed from fundamental philosophical differences about shipbuilding. German naval tradition emphasized craftsmanship, perfectionism, decades of experience, meticulous attention to detail. German shipyards employed highly skilled workers who spent years mastering trades and took pride in producing individually excellent vessels. German naval architects couldn't imagine that inexperienced American workers, many of them women, could possibly produce seaworthy ships using simplified construction methods and minimal training. German assessments predicted catastrophic failures when American ships encountered heavy seas or sustained battle damage. Those predictions proved spectacularly wrong. Liberty ships and other American merchant vessels demonstrated adequate structural integrity, surviving Atlantic storms, torpedo hits, and sustained operations under extreme conditions. Some ships experienced structural problems, including several that literally cracked apart, but overall, reliability proved sufficient for wartime needs. American production volume overwhelmed German submarine campaign because ships were being built faster than U-boats could sink them, creating decisive advantage that Kriegsmarine couldn't counter regardless of individual U-boat effectiveness. Your specific workstation involves welding hull sections in Fabrication Area B, where deck sections are assembled from steel plates. Steel plates arrive pre-cut to precise dimensions by automated cutting machines, eliminating need for skilled layout requiring machinists. Plates are positioned on assembly jigs, ensuring correct alignment without skilled fitters requiring judgment. Your job requires making vertical welds, joining plates creating continuous deck section. Each weld must meet quality standards ensuring structural integrity. Inspectors examine welds using visual inspection and occasionally magnetic particle testing, detecting subsurface defects. Defective welds require rework, consuming time and resources. Your personal pride drives maintaining quality standards because substandard work reflects poorly on women workers, generally providing ammunition to critics arguing women can't perform skilled trades adequately. Pressure is substantial, knowing that every weld you make either validates or undermines women's competence in industrial work. Physical demands of shipyard work challenge you constantly. Welding equipment weighs approximately 30 pounds, requiring sustained upper body strength. Welding positions require maintaining awkward postures for extended periods, causing muscle fatigue and pain. Heat from welding torches combined with California sun creates temperatures exceeding 100 degrees inside welding leathers, causing heat exhaustion. Arc flash from welding exposes eyes to ultraviolet radiation requiring protective equipment. Metal fumes from welding create respiratory hazards. Noise levels damage hearing. Sharp steel edges cause lacerations. Heavy equipment creates crush hazards. Falls from scaffolding cause serious injuries. Industrial accidents occur daily despite safety precautions. Several women died during war years from accidents demonstrating that shipyard work carries genuine danger regardless of gender. Yet women persist because wages substantially exceed alternatives. Patriotic duty motivates continuing despite hardships. Personal satisfaction from accomplishing difficult work provides motivation beyond financial compensation. Prefabrication system that you're working within represents revolutionary departure from centuries of shipbuilding tradition. Traditional shipbuilding started with keel positioned on construction ways, then built ship upward, sequentially installing components one after another until ship was complete enough to launch into water. That sequential approach meant only limited number of workers could work on ship simultaneously because most ship was inaccessible until structural framework was completed. Kaiser's modular approach divided Liberty Ship into 11 major assemblies and 69 sub-assemblies built simultaneously in different fabrication areas throughout massive shipyard complex. While you're welding deck sections in Fabrication Area B, other crews in Fabrication Area C are assembling complete deck houses, including all interior carpentry, wiring, plumbing, heating systems. Fabrication Area D produces complete engine assembly, 140-ton triple-expansion steam engine pre-assembled with all mounting structures, piping connections, control systems, ready for installation in single 8-hour operation using massive cranes. That parallel construction enables approximately 2,400 workers simultaneously working on single ship compared to traditional sequential construction limiting work crews to approximately 700 workers. Productivity advantage is overwhelming. Traditional methods require 6 months per ship. Kaiser's parallel prefabrication enables completing ships in 42 days average, representing nearly 5-fold speed improvement. Welding technology makes modular construction possible. Each Liberty ship requires approximately 50 miles of welding connecting steel plates and structural components. Welding uses electric arc, creating temperatures exceeding 6,500 degrees Fahrenheit, melting steel at contact point, enabling plates fusing together molecularly. Traditional riveting required overlapping plates held together by heated metal pins hammered through drilled holes. Skilled riveting crew could install perhaps 100 rivets daily. Each ship required approximately 1 million rivets, meaning riveting alone consumed 10,000 crew days. Welding eliminates rivets entirely while simultaneously reducing steel consumption because welded plates don't require overlapping. Welding training takes weeks rather than years required for riveting apprenticeship. That rapid training enables massive workforce expansion, incorporating inexperienced workers, including women who couldn't have entered shipbuilding profession under traditional apprenticeship system. German naval architects criticized welding as structurally inferior to riveting, arguing that continuous welded structures created crack propagation vulnerabilities that riveted structures prevented by isolating individual plates. That criticism proved partially valid when several Liberty ships suffered catastrophic structural failures, literally cracking apart. But overall, welding reliability proved adequate for wartime needs. Approximately 1,500 significant structural fractures occurred across 2,710 Liberty ships built, representing roughly 0.5 fractures per ship. Most fractures were minor, requiring relatively simple repairs. Approximately 19 ships suffered catastrophic failures. That 0.7% catastrophic failure rate proved acceptable compared to approximately 7.4% loss rate from enemy action, primarily U-boat torpedoes. Your specific role within massive production system demonstrates specialized division of labor, enabling rapid training and high productivity. You don't understand entire ship construction process. You understand vertical welding of deck plate sections. You've performed that specialized operation hundreds of times, developing proficiency through repetition. Other workers perform other specialized operations repeatedly. That extreme specialization enables training workers rapidly, but creates vulnerability when workers leave because replacing specialized workers requires retraining replacements. Management constantly struggles with labor turnover as workers leave seeking better wages elsewhere or return home after husbands complete military service. Richmond Shipyard No. 2 experiences approximately 5 to 10% monthly turnover, requiring continuous recruitment and training, maintaining workforce levels. Training schools operate continuously, processing new workers through programs teaching specialized skills needed for shipyard operations. Quality suffers somewhat from continuous workforce churn because inexperienced workers make mistakes that experienced workers avoid. But volume production compensates for quality variations. Better to produce adequate ships quickly than perfect ships slowly when strategic calculus favors overwhelming enemy through production volume rather than individual unit superiority. Women workers like you face discrimination and skepticism from male coworkers and supervisors. Some men resent women's presence, believing women are taking jobs that should be reserved for men. Union officials particularly resist women workers, arguing that hiring women will depress wages and establish precedent, undermining male employment security after war ends. Some supervisors doubt women's capabilities, assigning women to easier tasks, assuming women can't handle physically demanding work. Yet evidence demonstrates women perform equivalently to men at most shipyard operations when given proper training and opportunity. Statistical analysis comparing work quality between male and female welders shows no significant difference in defect rates or productivity. Women welders produce welds meeting quality standards at rates comparable to male welders with equivalent experience. Physical strength differences matter for some operations like heavy equipment handling, but most shipyard work emphasizes technique and precision rather than brute strength. Women develop techniques compensating for reduced upper body strength, leveraging body weight, using mechanical advantage, employing proper ergonomics, enabling accomplishing tasks that initially seem beyond physical capabilities. That adaptation demonstrates human capability for learning and improvisation when properly motivated. Rosie Riveter becomes iconic symbol representing women's wartime industrial contribution. Norman Rockwell's painting, published in Saturday Evening Post May 1943, depicts powerful woman wearing work clothes eating lunch sitting atop American flag background holding rivet gun across lap. That image captures public imagination, representing transformation of women's roles during wartime emergency. Real Rosie Riveters work at shipyards, aircraft factories, munitions plants, performing skilled industrial labor previously reserved exclusively for men. You personally identify with Rosie Riveter symbol, understanding that your work represents larger social transformation, challenging assumptions about women's capabilities and appropriate roles. Yet you also recognize that Rosie Riveter romanticizes shipyard work, obscuring harsh realities. Work is exhausting, dangerous, uncomfortable. Wages, while higher than traditional female employment, remain lower than male wages for equivalent work. Childcare responsibilities create constant stress as you worry whether your children are safe while you're working night shift. Housing shortages mean living in overcrowded conditions with inadequate facilities. Yet you persist because financial necessity requires income. Patriotic duty motivates contributing to war effort. Personal satisfaction from accomplishing difficult work provides motivation beyond external pressures. Medical support provided at Kaiser shipyards represents innovation addressing women workers' specific needs. Dr. Sidney Garfield, who established medical facilities at Kaiser construction sites, established comprehensive healthcare systems serving shipyard workers and families. Medical clinics treat work injuries and provide preventive care. Gynecologists develop fitness programs specifically preparing women for physical demands of shipyard work. Childcare facilities enable mothers working without leaving children unsupervised. That comprehensive support system demonstrates Kaiser's recognition that supporting workers' broader needs improves productivity and retention. Medical facilities treating 200,000 patients daily eventually evolve into Kaiser Permanente healthcare system, becoming one of nation's largest health maintenance organizations. That unexpected legacy demonstrates how wartime innovation catalyzes developments extending far beyond immediate military purposes, creating lasting institutions benefiting society decades after wartime emergency concludes. Race relations within shipyards reflect broader societal discrimination, while simultaneously creating opportunities for African Americans unprecedented in peacetime. Kaiser employs approximately 15,000 African American workers by 1944 in skilled and semi-skilled positions, including welding, fitting, crane operation. That employment represents progress compared to pre-war exclusion from skilled trades. Yet discrimination persists. Black workers face segregated facilities, harassment from white workers, limited advancement opportunities. White workers sometimes strike protesting black workers' presence. Management attempts managing racial tensions, maintaining production while balancing competing pressures from white workers resisting integration, black workers demanding equal treatment, government requiring non-discriminatory employment policies. Wartime emergency forces partial breakdown of discriminatory practices, creating precedent for post-war civil rights advances. Black workers who demonstrate capability performing skilled trades during war challenge assumptions justifying employment discrimination, providing evidence that racial discrimination reflects social prejudice rather than actual capability differences. Production statistics demonstrate overwhelming advantage that modular prefabrication provides. Richmond Shipyard No. 2 achieves peak production building 45 Liberty ships during single month in 1943. That's approximately 1.5 ships daily from single shipyard. Kaiser operates 7 shipyards simultaneously, plus knockdown kit production supplying other assembly facilities. Total Kaiser production reaches 1,552 vessels, representing approximately 27% of total maritime commission wartime shipbuilding. German Kriegsmarine produced approximately 1,150 submarines during entire war. American shipyards produced over 5,000 ships during comparable period, overwhelming German submarine campaign through sheer production volume, regardless of individual U-boat effectiveness. Strategic arithmetic becomes decisive. U-boats sink approximately 3,500 Allied merchant vessels during war, representing terrible losses. But Allied shipbuilding produces over 5,000 replacement vessels, meaning that net tonnage increases despite sustained German attacks. That production advantage, derived directly from revolutionary construction methods, enables winning Battle of Atlantic through industrial capacity rather than tactical superiority. Kriegsmarine's inability matching American production capacity becomes increasingly evident as war progresses through 1943 and 1944. German submarine force peaks approximately 210 operational U-boats available for Atlantic operations at end of 1942, representing maximum strength achieved despite years of construction effort. German shipyards produced 1,156 operational submarines total during entire war from 1935 through 1945, plus approximately 700 midget submarines added in final year. That represents approximately 120 U-boats annually averaged across war years. American shipyards during comparable period produced 2,710 Liberty ships alone, representing 4 times total German submarine production measured by number of vessels. When including other American merchant ship construction, victory ships, tankers, troop transports, specialized cargo vessels, American production exceeds German submarine production by greater than 10-to-1 ratio. Strategic arithmetic becomes devastatingly clear. U-boats sink approximately 3,500 Allied merchant vessels during war, representing terrible losses. But Allied shipbuilding produces over 5,000 replacement vessels, meaning net tonnage increases despite sustained German attacks. Kriegsmarine strategy depends on sinking ships faster than Allies can replace them, creating tonnage crisis, forcing Britain into negotiated peace. That strategy fails because German naval architects fundamentally underestimated American industrial capacity and revolutionary construction methods, enabling production volumes that traditional shipbuilding approaches couldn't achieve. German submarine construction methods reflect traditional craftsmanship approach, emphasizing individual vessel quality rather than mass production volume. German shipyards employ highly skilled workers who spent years learning trades through comprehensive apprenticeship programs. Each submarine is essentially custom-built with craftsmen hand-fitting components, individually adjusting systems, meticulously inspecting every detail, ensuring perfect quality standards. That approach produces excellent individual vessels. Type 7 U-boats represent superb engineering combining reliability, operational effectiveness, crew survivability in compact design, displacing only 769 tons surfaced. German submariners respect Type 7 reliability, trusting boats to perform under combat conditions. Yet production rate remains constrained by craftsman-based construction limiting output. German shipyards produce approximately 20 U-boats monthly at peak production 1943, representing extraordinary achievement given resource constraints Germany faces. But 20 monthly represents inadequate production, replacing combat losses while simultaneously expanding submarine force, threatening Allied supply lines. German submariners suffer catastrophic 67% casualty rate, with 784 submarines lost from total production of 1,156 operational boats. That loss rate exceeds replacement rate, forcing submarine force contraction rather than expansion as war progresses, despite Germany desperately needing expanded submarine capability countering Allied naval superiority. German leadership recognizes production disadvantage and attempts implementing revolutionary approaches late in war. Type 21 Electroboot represents radical design change, creating first genuine submarine rather than submersible. Type 21 operates submerged continuously using advanced battery technology, streamlined hull design, snorkel breathing apparatus enabling underwater operation without surfacing. Type 21 represents technological breakthrough, potentially negating Allied anti-submarine warfare advantages. But Type 21 arrives too late. First boat launches April 1944. Production ramps slowly. Total 119 Type 21 submarines completed before war ends, May 1945. Only handful become operational. None see combat action. That failure stems from multiple factors, including Allied bombing, disrupting production, resource shortages, limiting construction, technological challenges requiring extended testing, workforce limitations preventing rapid expansion. Most critically, Type 21 incorporates modular construction methods similar to American approach, dividing submarine into 8 prefabricated sections built simultaneously, then assembled using specialized facilities. That revolutionary approach, same approach German experts derided as stupid when Americans implemented for Liberty ships, arrives too late for Germany implementing when war is already lost. Had Germany adopted modular construction methods earlier, potentially achieving production volumes comparable to traditional approaches while maintaining quality standards, submarine war might have developed differently. But German naval tradition emphasizing craftsmanship and individual excellence prevented reconsidering fundamental construction approaches until desperation forced change when too late, making difference. Your personal experience as woman welder at Kaiser Shipyard directly contradicts German assumptions about workforce requirements for modern shipbuilding. German naval architects assumed shipbuilding required physically strong male workers possessing years of specialized training, making rapid workforce expansion impossible without compromising quality. You and thousands of other women demonstrate those assumptions are false. After 6 weeks training, you're producing welds meeting quality standards at productivity levels comparable to experienced male workers. Physical strength matters less than technique, precision, attention to detail. Qualities women possess equivalently to men when given proper training and opportunity. That fundamental insight about human capability challenges centuries of assumptions justifying excluding women from skilled trades. German industry, facing similar labor shortages, attempted employing women, but German cultural attitudes toward women's roles proved more resistant than American attitudes limiting German ability, expanding workforce through female employment. Some German women worked in munitions factories and other war industries, but cultural resistance prevented full mobilization of female labor potential. American cultural attitudes, while still discriminatory, proved more flexible, enabling massive expansion of female industrial employment. That cultural flexibility, combined with revolutionary production methods, created decisive advantage, enabling America overwhelming Axis production capacity despite entering war years after Germany and facing multi-theater global conflict, stretching resources across Pacific and European theaters simultaneously. Evidence from operational experience validates American construction methods despite German criticism. Liberty ships survive Atlantic storms, torpedo hits, battle damage, proving adequate structural integrity for wartime service. Merchant mariners sailing Liberty ships report generally positive experiences, praising ships' handling characteristics, cargo capacity, reliability. Yes, some ships experience structural problems. Yes, several ships literally crack apart catastrophically. But overall, reliability proves sufficient. Statistical analysis shows Liberty ships complete approximately 2,500 combat voyages per ship lost to structural failure, compared to approximately 40 combat voyages per ship lost to enemy action. Structural failure risk proves negligible compared to enemy action risk. Strategic calculus favors accepting minor structural vulnerability in exchange for tenfold production advantage, overwhelming enemy capacity sinking ships. That pragmatic calculation, accepting adequate rather than perfect solutions when adequate proves sufficient, represents fundamentally American approach to military problems, contrasting with German perfectionism, insisting on optimal solutions regardless of time required achieving perfection. Speed matters more than perfection when strategic objective requires overwhelming enemy through production volume rather than individual unit superiority. Your daily work routine demonstrates systematic organization enabling high productivity despite workforce inexperience. Each morning you arrive at shipyard riding bus from housing area, where you share apartment with 3 other women working various shipyard positions. You change into work clothes, including special welding leathers designed for women with shorter torso, narrower shoulders, space-accommodating breasts that standard male welding leathers didn't provide. You collect welding equipment from tool crib, checking torch assembly, confirming gas supplies, verifying all safety equipment functions properly. You proceed to Fabrication Area B, where deck sections are assembled, receiving work assignment from supervisor who directs you to specific welding station. You review work order specifying weld locations, joint types, quality requirements. You position workpiece using assembly jigs, ensuring correct alignment without skilled fitting requiring judgment. You perform welds following procedures learned during training, maintaining consistent arc length, proper travel speed, correct electrode angle. You complete weld and a signal inspector who examines weld, visually verifying acceptable quality. Acceptable welds receive approval mark allowing workpiece continuing through assembly process. Defective welds require immediate rework, delaying workpiece and reducing productivity. Your personal pride drives maintaining quality because you understand that every defective weld reflects poorly on women workers, generally providing ammunition to critics, arguing women can't perform skilled trades adequately. Pressure is substantial, knowing that your performance either validates or undermines women's competence, proving or disproving women's capability for industrial work. Social life outside shipyard provides essential support, enabling you continuing despite physical exhaustion and emotional stress. You share apartment with 3 other women working various shipyard positions, creating mutual support network. Women help each other managing household responsibilities, sharing childcare when work schedules conflict, providing emotional support when work becomes overwhelming, celebrating achievements and commiserating about difficulties. That informal support network proves essential for women lacking extended family support that traditional communities provided. Richmond's rapid growth from 24,000 to 100,000 population means most residents are newcomers lacking established social connections. Women particularly feel isolation, being away from families, separated from husbands serving military, raising children without traditional support systems. Creating makeshift communities through shared housing, workplace friendships, organized social activities becomes survival necessity, enabling women persisting despite difficulties. Kaiser establishes recreation facilities including athletic fields, community centers, social clubs attempting providing social infrastructure supporting workforce. Women particularly appreciate organized activities enabling meeting other women, sharing experiences, building friendships, sustaining morale through difficult periods. War ends August 1945 with Japan's surrender following Germany's collapse 3 months earlier. Richmond shipyards begin shutting down operations immediately as military contracts are canceled and production ceases. You receive notice that your position will be eliminated within 30 days as shipyard workforce undergoes massive reduction, returning to peacetime employment levels. Approximately 80% of women workers lose shipyard employment within 6 months of war's end as returning servicemen reclaim jobs and defense industry contracts evaporate. That sudden displacement creates economic hardship for women who became primary family breadwinners during war years. Some women return to traditional female employment as waitresses, clerks, domestics, accepting substantially lower wages than shipyard work provided. Some women marry or remarry, establishing traditional family arrangements where husbands provide income. Some women struggle finding any employment, facing discrimination from employers who prefer hiring male workers and from male workers who resent women competing for scarce jobs. Your personal circumstances force accepting waitressing position, earning half what shipyard welding paid despite demonstrating equivalent welding competence to male workers during war years. That economic regression represents bitter pill swallowing after proving women's capability performing skilled industrial labor equivalently to men. Yet wartime experience creates lasting transformation despite immediate post-war regression. Women who worked in shipyards, aircraft factories, munitions plants demonstrated conclusively that women possess capability performing skilled industrial labor when given proper training and opportunity. That demonstration challenges centuries of assumptions justifying excluding women from skilled trades based on supposed inherent limitations. Pre-war arguments that women lacked physical strength, mechanical aptitude, emotional stability for industrial work proved false through wartime experience. Some women lacked those qualities. Some men lacked those qualities. Individual variation proved more significant than gender differences when evaluating capability for industrial work. That empirical evidence provides foundation for post-war feminist movements advocating workplace equality based not on ideological assertions about equality, but on demonstrated evidence that women perform equivalently to men at most occupations when discrimination is removed. Civil rights legislation passed decades later, including Equal Pay Act 1963 and Civil Rights Act 1964, prohibiting employment discrimination traces intellectual lineage directly to wartime demonstration that women could perform industrial work, challenging assumptions justifying discriminatory employment practices. Statistical evidence documenting women's wartime contribution becomes powerful argument supporting equal employment opportunity. Approximately 6 million women entered workforce during World War II, increasing female labor force participation from approximately 25% pre-war to 37% at war's peak. Women comprised approximately 65% of aircraft industry workforce, 40% of shipyard workforce, substantial percentages in numerous defense industries. Quality studies comparing male and female worker performance show no significant differences in productivity, defect rates, safety records when controlling for experience levels. Those studies provide empirical evidence contradicting discriminatory assumptions that women produce inferior work. Post-war advocates for women's employment rights cite wartime studies demonstrating women's capability as evidence supporting equal opportunity employment policies. Though progress occurs slowly over decades rather than immediately after war, wartime precedent provides foundation enabling gradual transformation of employment opportunities available to women. Your personal life after war reflects broader patterns experienced by wartime women workers. You struggle financially adjusting to lower wages after losing shipyard employment. You experience frustration knowing you demonstrated welding competence but can't find welding employment because employers preferentially hire male workers. You eventually marry returning serviceman who provides stable income, enabling establishing traditional family arrangement where you focus on homemaking and child rearing while husband provides income. That traditional arrangement provides financial security, though you occasionally miss independence and accomplishment feeling that shipyard work provided. Decades later, reflecting on wartime experience, you recognize contradictory feelings: pride at having contributed to war effort and demonstrated women's capability, frustration that demonstration didn't immediately translate into permanent employment opportunities, satisfaction at having accomplished difficult work under challenging conditions, awareness that your generation's experience opened doors for subsequent generations even though immediate benefits proved limited. Modular construction methods that German experts derided as stupid become standard practice in post-war shipbuilding worldwide. Prefabrication enables constructing ships faster and cheaper than traditional sequential construction. Japanese shipyards particularly embrace modular construction, becoming world leaders in commercial shipbuilding during post-war decades. Korean shipyards later adopt similar methods, achieving dominant market position. American shipyards, ironically, lag behind adopting methods Kaiser pioneered during war because Union resistance to productivity improvements and management complacency in protected domestic market prevent competitive pressure, forcing innovation. That competitive decline demonstrates that wartime innovation doesn't automatically translate into peacetime advantage without sustained commitment to continuous improvement. Technology transfer occurs globally, with competitors learning lessons from American wartime innovations and applying those lessons more effectively than originators, because competitors face competitive pressure, forcing excellence, while originators enjoy temporary monopolies enabling complacency. Liberty Ship operational record vindicates American construction methods despite German criticism. Approximately 200 Liberty ships were sunk by enemy action during war, representing 7.4% loss rate. Approximately 19 ships suffered catastrophic structural failures, representing 0.7% failure rate. Strategic arithmetic clearly favors accepting minor structural vulnerability in exchange for production volume overwhelming enemy capacity. Ships built by women welders and inexperienced workers proved as reliable as traditionally constructed vessels, demonstrating that specialized training combined with simplified assembly procedures produces adequate quality for wartime needs. Post-war service life for surviving Liberty ships varies widely. Some ships operated commercially for decades as tramp steamers carrying bulk cargo worldwide. Greek shipping companies purchased hundreds at surplus prices, operating them profitably into the 1970s and 1980s. Other ships were scrapped immediately as surplus exceeding commercial needs. Some entered reserve fleets maintained as strategic emergency reserves. By 1990s, virtually all Liberty ships had been scrapped except 2 museum ships and handful preserved as memorials. German submarine force suffered catastrophic casualties, demonstrating that tactical excellence couldn't overcome strategic disadvantage. Approximately 1,156 operational U-boats commissioned during war. Approximately 784 submarines lost, representing 68% loss rate. Approximately 30,000 German submariners killed from total approximately 40,000 serving, representing 75% casualty rate. Those horrific statistics reflect fundamental strategic miscalculation by German leadership, expecting submarine warfare would strangle British supply lines, forcing negotiated peace. That strategy depended on sinking ships faster than Allies could replace them. German submarine force sank approximately 2,800 Allied merchant vessels, totaling approximately 14 million tons. American shipyards produced 2,710 Liberty ships, totaling approximately 27 million tons, plus thousands of other vessels. Net tonnage increased despite sustained German attacks, proving submarine strategy failed because German leaders fundamentally underestimated American industrial capacity and revolutionary construction methods, enabling production volumes traditional approaches couldn't achieve. Rosie Riveter legacy extends beyond immediate wartime contribution, creating lasting cultural symbol representing women's capability and independence. That symbolic significance matters perhaps more than immediate employment impact, because symbols influence how societies think about possibilities. Pre-war cultural assumptions insisted women belonged home, caring for families rather than working in dangerous industrial facilities. Rosie Riveter challenged those assumptions, demonstrating women could perform industrial work successfully. Post-war cultural resistance prevented immediate translation into permanent employment opportunities, but precedent was established. Subsequent generations, citing Rosie Riveter example, advocated expanding women's opportunities across multiple domains, including skilled trades, professional occupations, leadership positions. That gradual expansion occurred over decades, reflecting slow cultural change, but wartime precedent provided foundation enabling change that might not have occurred without demonstration during national emergency, when traditional barriers temporarily dropped, allowing women proving capabilities. Your final reflection, decades after wartime service, emphasizes unexpected lessons about human capability under pressure. Before shipyard employment, you doubted whether you could handle physically demanding industrial work. Society insisted women lacked necessary strength and aptitude. Yet with proper training and determination, you successfully performed skilled welding, meeting quality standards. That personal accomplishment proved more significant than immediate financial benefit because it demonstrated to yourself that societal assumptions about limitations were false. Discovering personal capability exceeding societal expectations proves empowering experience, influencing how you approach subsequent challenges throughout life. Wartime service taught that limitations are often socially constructed rather than inherent, and that extraordinary accomplishments become possible when people are given opportunities demonstrating capabilities. That lesson about human potential applies beyond gender, extending to assumptions about capabilities based on race, class, education, background. Wartime emergency forced temporary suspension of discriminatory barriers, allowing people demonstrating capabilities that peacetime prejudice prevented. Those demonstrations created evidence challenging assumptions and establishing precedents, enabling gradual social transformation over subsequent decades.